Today we're going to have a crash course in cosmology. But to start, we need to first look at some of the basics of the universe. So first, what is matter made of? So everything is made up of tiny particles called atoms. And these are very small building blocks that make up all the stuff that we see around us. So you can have atoms of, say, oxygen or carbon or hydrogen. These are the building blocks of everything we see. But these atoms are actually made up of even smaller things. So for every atom, there is in the center a nucleus made up of particles called protons, which are positively charged, and particles called neutrons, which have no charge. And then swirling around them, flying around them, are these little particles called electrons, which are negatively charged. So in the atom, we have the nucleus with protons and neutrons, and the electrons flying around. But then we can actually delve further in still. And it's been discovered that protons and neutrons are both made up of even smaller particles called quarks. So each proton has 3 quarks, each neutron has 3 quarks, and then still all around them is flying the electrons. It's like, okay, now I've got a basic picture of what matter is made of. But it actually gets even stranger still, as scientists use particle accelerators to send particles at very fast speeds to collide with each other and see what other things appear. And they find, first of all, there's actually 6 different types of quarks. There's top, bottom, charmed, strange, up, down, all slightly different sizes, but similar ideas, similar types of properties. Then there's other really crazy things called neutrinos. The neutrinos are particles that are formed in radioactive decay. And so the sun is emitting tons of neutrinos all the time. In fact, you and I are always in a stream of neutrinos that's coming from the sun. We're surrounded by them. But these particles interact very weakly. They don't affect us at all. They're so small and so weak that they just pass through us without doing anything to us. And they can actually go deep into the earth before they're stopped. They have very little interaction with anything else. But they exist, and as we'll see later, they're actually very important. And they were discovered in a laboratory deep under the earth. They were actually able to detect these neutrinos. And these different types of quarks and different types of neutrinos are just a few of the crazy particles. There's a list of tons of different particles discovered in these particle accelerators. And then to top it all off, for all this matter, there's something called antimatter. So for instance, there's an electron, a small particle with a negative charge, but there's also an anti-electron or a positron that has positive charge. But when these two come together, they annihilate, they cancel each other out and turn into an explosion of energy. So for all these different types of particles that could make up matter, there's antiparticles, which are antimatter, that if they interact, they'll annihilate and turn into energy. So that's a basic view of matter, but then all matter and all the universe is also dominated by 4 forces. These forces are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. So gravity we're all familiar with. It's what makes apples fall to the ground. What keeps the sun moving around the galaxy, what keeps the earth moving around the sun, what keeps the moon moving around the earth. We're pretty familiar with this force. This is one of the big ones. Another one is the electromagnetism. This is what light is. Light and radio waves are. Is there this type of electromagnetic waves, and it's also what electricity is and what magnetism is, hence the name electromagnetic force. And so the positive charge in protons and the negative charge in electrons, they're attracted to each other. This is what holds them together, and that's a type of electromagnetic attraction. But then there's this other force called the strong nuclear force, and that's what holds the protons and the neutrons together, and also holds together the quarks inside the protons and neutrons. And at short distances, the size of the nucleus, it's incredibly strong, but then it gets weak over long distances. So it's only really important right there in the nucleus. But it plays a huge role. It's what keeps the nucleus together. And then there's this 4th force called the weak nuclear force. And as the name suggests, it's very weak, but it's involved with radioactive decay and with those particles we just talked about called neutrinos that are emitted. And while it is very weak, it has an important role, as we'll see, in something called supernovas. Thanks.